Let me talk about this magic number E, sometimes called Euler's number. This is a constant named after Leonhard Euler, a very prominent Swiss mathematician. And E was first referenced to by John Napier in 1618 while constructing a table of logarithm. And it's considered to be discovered by Jacob Bernoulli in 1683 while studying compounding interest. So the discovery of E is another example of Stigler's law of eponymy, which states that no scientific discovery is named after its original discoverer, because here the real discoverer is Jacob Bernoulli, but somehow this number is named after Euler, abbreviated as E. E is a rational number. That is, it can be expressed as a fraction, and it is approximately equal to 2.71, 8281, 8284, 5904, and the decimal continues. Okay? And this number E can be expressed as two mathematical equations exactly. The first is E is equal to the limit of the function 1 plus 1 over n. So the addition raised to the power of n. And here, n needs to be a positive integer. And this formula, 1 plus 1 over n raised to the power of n, comes from compounding interest. So let's say the total annual interest is 100%. So that is 1, okay? And we want to collect interest, let's say quarterly. So n is equal to 4. For monthly, then n is equal to what? 12. And daily, okay, it is equal to what? 365. When n approaches infinity, positive infinity, taking limit of this function, then this function going to approach what? E. So that's one mathematical expression of E. The second mathematical expression of E is an infinite series of summation. So let's say for n equal to 0 to infinity, and we want to add up all this function, 1 over n factorial, 1 over n factorial. And people might have questions about what factorial is, right? So what is a factorial? So k factorial, let's say k factorial. What is k factorial? Well, k factorial is equal to what? 1 multiplied by 2 multiplied by 3 and continues until it hits what? Multiplied by k. So let's say 1 factorial is equal to what? 1, well, that's the only element we have, right? 2 factorial is equal to what? Equal to what? 1 multiplied by 2, and 3 factorial is equal to 1 multiplied by 2 multiplied by 3, right? And it continues. And a unique fact is 0 factorial is equal to what? Equal to 1, okay? Then for this summation, sigma n equal to 0, right? To infinity, 1 over n factorial. What is this summation equal to? An infinite series. Well, is what? 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial, right? Plus plus what? Well, it continues forever. When we sum up all these 1 over some factorial, okay, we'll get what? E. So both functions is going to lead to e, which is a rational number, right? And let me quickly talk about some basic operations of natural exponential function. So this function uses e as its base and power x. First, a very interesting fact, just need to know is a function of e raised to the power of x is its own derivative, okay? And then the next rule is what we call the product rule. So let's say we use e as our base, right? So we have first term e raised to the power of a, okay? Second, we have term is e raised to the power of b. And when we multiply these two terms together, we can simply add the power, that is a plus b. Okay? We will get the result. And this is called product rule. This is called the product rule. So I can give you an example, right? E raised to the power of, let's say, 2 multiplied by e raised to the power of 5. What is that equal to? Equal to e raised to the power of 7. And this rule is not unique to e, okay? We can use other numbers as base here, right? So let's say we use base, 3.14. Let's say 3.14 raised to the power of 5. Multiply by 3.14 raised to the power of 2. What do we get? We get equal to 1.34 raised to the power of 7. So we simply add together exponents. Okay? Exponents. Okay, and let's continue. And the next rule is called the division rule. And basically, it turns division into what? Into subtraction. The first is called product rule. It turns multiplication into what? Addition. So let's look at division rule. Division rule says, well, let's say we use, again, e as the base. E raised to the power of what? Of a, right? Divided by e raised to the power of b. What do we get? Well, it is equal to e raised to the power of a minus b. So here I can give you an example, right? E raised to the power of 3 divided by e raised to the power of what? 2. Then we get e raised to the power of what? 3 minus 2 equal to what? E raised to the power of 1. And again, this division rule does not only apply to base e. It can be applied to any number used as base. So let's say pi. Okay, pi raised to the power of 10 divided pi raised to the power of 2 equal to what? Pi raised to the power of 10 minus 2. That is equal to what? Pi raised to the power of 8. Okay, so this is called the division rule. It's called division rule. And let's look at the next rule here. It's called power rule. So let's say we have this term. Again, use e as the base, raised to the power of a. Okay, raised to the power of a. Then we want to raise the whole term. That is e raised to the power of a raised to the power of b. Okay, raised to the power of b. Then what do we get? Well, we simply multiply the two exponents. Okay, so it is turning exponential function into what? Multiplication. So one major nice feature of exponential function is to downgrade the operational level, right? From exponent to multiplication, from multiplication to addition, etc. Simplifying the computation to a great extent. So let's move on to next. Well, this slide talks about how to prove that the derivative of the natural exponential function, that is e raised to the power of x, is equal to itself. Okay, and here I'm not going to get into detail because this is relatively complicated and it is optional. So let's look at a graph of this natural exponential function. So on the x-axis, basically, we can take on any values on the real line, right? So x can be equal to anything on the real line. But what is y equal to? Y, well, y has to be a positive number. An interesting fact is that when x is equal to 0, right? What is y equal to, or what is e raised power of x equal to? Oh, here exactly it is equal to what? E raised to power of 0. What is that equal to? Well, that is equal to what? 1. That is equal to 1. Okay. And